Fine. We'll see about the base data type. In C language, there are totally 4 base data types. That is an integer, float, double, and char. So this integer is the one where you can store an whole numbers, that is without decimal point. Whereas float and double both are meant for storing a floating point value. Whereas in character, you can store any type of character which is available on the keyboard. A single character can be stored. So in detail, we'll discuss one by one. So actually this integer will occupy 2 bytes. That means if you declare any integer variable x in a random access memory, 2 continuous blocks will be allocated. So each block in a RAM is made up of 1 byte. So that means 2 blocks have been stored. Here this is called as a lower byte, and this one is an upper byte block. Okay. So we'll see about that, how the data has been stored. So integer will occupy 2 bytes. Same way, float will occupy 4 bytes, whereas double will occupy 8 bytes, and character will occupy 1 byte. Okay. So first we'll discuss about int data type. So as I said, integer will occupy 2 bytes. Now if I give here int of x, so continuous 2 bytes has been allocated. 2 bytes means total 16 bits has been allocated. So let's take this as a lower byte and this one as an upper byte. So lower byte is made up of 8 bits. We'll number this from 0, 1, 2, 3, 4, 5, 6, 7. Same way, we'll number this is an upper byte. Again, it's made up of 8 bits. 8 bits, number it from 8, 9, 10, 11, 12, 13, 14, and 15. That is total 0 to 15, 16 bits. 16 bits means nothing but 2 bytes. So 0 to 7 is nothing but lower byte, and 8 to 15 is nothing but an upper byte. Okay. Fine. How exactly the data has been stored? If I give here x is equals to 25, how the 25 has been stored? Actually, 25 is not stored. All the data are stored in the form of zeros and ones here. So what is the binary value of this 25? So if you divide it by 2, you'll get the binary value. So 2 12s are 24, 1 is the remainder. 2 6 are 0 is the remainder. 2 3s are 6, 0 is the remainder. Here 2 1s are 1 is the remainder. So the binary value of this 25 is nothing but 11001. So how does 11001 has been stored? So here 11001. This is the data, how it's been stored. And in rest all locations, you'll be having nothing but zeros. All these locations you'll be having a 0. That is, this first 15 bits are been treated as, an data bits. Okay, there are totally 15 bits. And the last bit is been treated as an sign bit. Okay. Now, here the sign bit indicates whether this 15-bit location is having a positive value or is it having a negative value. If you have any of this 25 is a positive value. If you have a positive value in this sign bit, a 0 value has been stored, whereas if it is a negative, then 1 will be stored in the sign bit. Because this 25 is a positive, here at present you'll be having the value as 0. Okay. So this is how the data has been stored. Next we'll see here, what is the maximum value we can store in an integer, maximum as well as a minimum value. Now to explain that, instead of taking here 15 bits, I'll consider here only 4 bits. Okay. Assume that there are 4 bits here, and of this 4 bits, 3 are data bits and the last one will be as you take it as a sign bit. Now if it is in 3 location, what is the maximum binary value I can store? The maximum binary value I can store is nothing but 111. Okay, that's the maximum value you can store. Now if it is 111, it is a base of 2. Then what is its equivalent base of 10 value? What is the decimal value? So how do you find out that? So this 111, you multiply it by 2 raised to 0, 2 raised to 1 and 2 raised to 2. 2 raised to 0 is 1. Here this is 2 raised to 1 is 2. This is 4. 2 raised to 2 is 4. And multiply this both. It's going to be a 1 plus this is 2 plus this 4. It's going to be nothing but 7. So that means in a 3-bit location, maximum decimal value you can store is nothing but a 7. This is one way of doing it. Second way is, very simple way is, you can just calculate here 2 raised to how many bits you have here, how many data bits you have here. You have here 3 bits, 3 data bits. So 2 raised to 3 minus 1, that comes down to again nothing but 7. Okay. Similarly, if you are having a 4-bit location, 4-bit data location, okay, that's total 5 bits. In that case, you can store here is nothing but, that is 4 ones. 4 ones is going to be nothing but 2 raised to 4 minus 1. 2 raised to 4 is nothing but 16 minus 1, it's going to be 15. So 15 is the maximum value you can store in this location. Now, why 15? Why can't I store 16? If you take in 16s, what is the 16's binary value? 16's binary value divided by 2. So 2 8s are 0 is the remainder. 2 4s are 8, 0 is the remainder. 2 2s are 4, 0 is the remainder. 2 1s are 2, 0 is the remainder. So take the value from the bottom, it's going to be a 1 0 0 0 0. Okay, it's going to be a 1 0 0 0 0. So now, how many bit data it is? The 16 decimal values binary equivalent is nothing but 1000. That is total. Here you have 5 bits. Now, can I store this 5 bits in a 4-bit data location? It is not possible. Of course, it is possible. What it does is, it will store your 0 0 0 0, and that 1 whatever is there, that will be stored in a sign bit. So when 1 is been stored in a sign bit, then the whole data is negative. And the negative data are not stored. Negative data are not stored as the positive data. Negative, when you try to store any negative data, it's one's complement will be stored. So that means this value will become here 1. Because this is an 0 0 0 0, all these zeros will be converted to ones, because all negative numbers are stored in the form of ones complement. So this becomes here nothing but negative 16. Got it? It becomes a negative 16. So that means if you store here 16 value, it will be stored as a negative 16 rather than positive 16. So that means in a 5-bit location, the smallest value you can store is minus 16, and the maximum value you can store is nothing but plus 15. Why here 1 less is because your positive number starts from 0, whereas negative number starts from minus 1. So the range of value you can store in a 5-bit location is nothing but minus 16 to plus 15. Similarly, in an integer, you have your 15 data bits. If it is in 15 data bits, then what is the value you can store? So 2 raised to 15 minus 1 is the value you can store. So 2 raised to 15 minus 1, that comes down to an 32,767. And the smallest value you can store is nothing but minus 32,768. Okay, so this is the range of value you can store in an integer variable in C language. So that is minus 32,768 to plus 32,767. You cannot store more than this, nor you can store smaller than this. If you try to store more than this, it will not give any error message. It gives you a negative value. As I explained here, if you try to actually in a 5-bit location, maximum decimal value you can store is nothing but 15. But if you try to store 16, it will be stored as a minus 16.